Okay, so today we're going over two chapters, handling data 3 and handling data 4 from my book. The first idea is going to be dispersion. What is dispersion? It's basically a way to measure how spread your data is, okay? How much spread is there in your data, okay? Like in a very in a very subjective sense, like if you have 1, 2, 3, and 4, these are your four data points, and then you have 1, 200, 3,000, and 40,000. As you can see, like one of these is clearly much more spread out than the other. And I don't mean like, the way I've written it. I mean the numbers themselves are very far apart, right? So we call like you see that this is less spread apart and this is more spread apart. So we call this to have higher dispersion basically. But of course, we want to talk about more like concrete ways to actually measure stuff, right? There are a few things. The first thing is called the median of your data. The median of your data is basically the central value, okay? So the median has two cases, okay? The first case is, let me show you both of them by example. Let's say this is one of your data sets, and let's say that this is your other data set. Now, here's what you do. The median is basically whichever value is sitting in the middle of your data if you obviously put it in ascending order, okay? So if you put it in order like this, what is the value sitting in the dead center of your data? So as you can see in this case, it's pretty easy to see that it's 3, okay? But how do we find this in general? To find this in general, count how many terms you have. In this case, we have how many terms? 1, 2, 3, 4, 5. So we have 5 terms or 5 elements in this set. Divide your number of terms by 2, you get 2.5. Round it up, and that term, the third term, is the median. Okay, so divide it by 2. If you get a decimal, round the decimal up by, round the decimal up. That term is your median. So the third term is your median. Okay, it's as simple as that. However, what if you have another situation? By the way, is this clear?
Yeah.
Okay. Now, what if you have a situation where you have an even number of terms? You see, in this case, you have 6 terms. And here, it's not as easy to see what is in the center because there is no clear center, right? Because now, if you look at these two terms, the center would be somewhere in the middle here, right? That would be the center of your data. So how do we do this? Well, we try to find the average of the middle two terms. So we're going to try to find the average of these two guys, and that's going to be the median for us. But how do you do it in general? Just like last time, take your total number of terms, divide it by 2, you get 3. Okay? That means in this case that your third and fourth term needs to be meaned, so average, to get median. Okay? So in the case where the half of your number of terms is a whole number, you need to take that term and the next one and average them. So the third term and the fourth term need to be averaged to get the median. Does that make sense?
Yeah.
So in this case, the median would be 3 plus 4 over 2, which is 3.5, which makes sense because it's in the middle of 3 and 4. So these are the two cases of how you can find medians. There is no other case. Either you will have an odd number of terms or you will have an even number of terms. And this is the method for both of them. So this is the first measure of your dispersion. Then you have quartiles. What is a quartile? It's basically very similar to a median. So let's say that, let me pull out a data set from like the book to make life easier for myself. So for instance, let's say you have 16 data points as shown here. So as you can see, these are 16 data points that are arranged in ascending order and blah, blah, blah. Since there are 16 terms, To find the median, I need to divide the total number of terms by 2. I get 8, which means that the 8th and ninth term average is my median. Okay, we already know how to find the median though, so this is pointless. How do we find what are quartiles? So you see, median is the 50% of your data. Okay, so the exact half of your data. That's why we find the center of our data. Okay, then you have the lower quartile, which is the 25% of your data. And then you have the upper quartile, which is the 75% of your data. Okay, so these are your quartiles. So median means 50%, lower quartile means 25%, upper quartile means 75%. So how do we find these? Similar method to your median. So let's try to find the lower quartile first. So for the lower quartile, you take your 16 terms, and instead of dividing it by 2, you divide it by 4 because you want to find the 25%. You want to find the quarter, right? So you multiply by 1 over 4 instead of 1 over 2. That gives you 4. Since this is a whole number, the process is the same. We need the fourth and fifth term mean. So what is the fourth term? 13. What is the fifth term? 15. So the mean will be 13 plus 15 over 2, which is 28 over 2, which is 14. So this is called your lower quartile, LQ. Okay? So the only difference between median and lower quartile is that instead of dividing by 2, you're dividing by 4. The rest of the method is the same. If you get a decimal answer, round it up, that is your lower quartile. If you get a whole number answer, take that one and the next one and find their mean. That is your lower quartile. Is this clear?
Yeah.
Okay. Now, for the upper quartile, same thing. So can you try to help me find out the upper quartile? So try to follow the same process. Total number of terms is 16. What do you think I will multiply 16 by?
3/4.
3 over 4, because I want the 75%. So 3 quarters. Okay. What is 16 times 3 over 4? I didn't hear you, by the way. Did you say something? Okay, anyways, 16 times 3 over 4 is going to be 12, which means that which terms do I need to find the average of? Leona, are you there?
Can you hear me?
Yeah, I can hear you now. So 16 times 3 over 4 is 12, which means that I need to find the average of which two terms?
The 12th and the 13th.
Exactly. Which means that we have 16 terms. So this is 16, 15, 14, 13, 12. So this is 12, this is 13. 25 plus 25 over 2, which is 25. That's the upper quartile. Now, now that we know the upper and lower quartile, we can find something called the interquartile range, which is thankfully very easy to find once you know about the upper and lower quartiles. It's literally the upper quartile minus the lower quartile. By the way, we write it like this. We say Q1, Q3, and the median is sometimes called Q2. So basically in your data, you have the lower quartile Q1, median Q2, upper quartile Q3. Okay?
All right.
So the interquartile is basically the upper quartile minus the lower quartile, which gives you 25 minus 14, which is 11 in this case. Okay? So the bigger this number is, the more spread out your data is basically. Because if there's a very big difference between your lower quartile and your upper quartile, that means your data must be very, very spread out, right? So this helps you kind of get a feeling for how spread out your data is. You see what I mean?
Yeah.
So this is your first measure of dispersion. Are there any questions?
No.
Perfect. Okay. So here's a question that you can expect, a 3, maybe 4 pointer question. You have a bunch of data with a missing point in it. You don't know this value. However, you know the Q2. Can you remind me what Q2 represents? Is it the lower, upper, or median?
Medium.
Yep, it's the median. So if the median is known to be 6, let's see if we can find out what x is. Okay, first of all, how many data points do we have? We have 9 data points. Okay, which means that the median is at, if you do the half of 9, by the way, you get 4.5. So where is the median then? If you get a decimal answer, what do you do to find the median position?
Round out 75.
Round it up. So it's going to be at the fifth term. 1, 2, 3, 4, fifth. That is your median. Huh? How is that possible? What? The median is 6? Hmm. Wait. Ah, wow. I made the most elementary mistake. Look, your data is not arranged properly, so we don't know where x is even going to be. So let's arrange it first. So 2, 2. So you got 2, 2, and then we have 4, and then we have 5, and then we have 8, and then we have no, we have 2 8s, and then we have 9 and 9. And the x is, where is x gonna go is the question, right? So we need to plug in an x over here somehow. First, let's try to figure out what so if the median is 6, okay, and we know that there are 9 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9. If there's 9 terms, then we know that the median will be at the fifth term, right? So if the median is at the fifth term, then the median has to be somewhere here. And if we put the x over there, then x is at the median position. So if x is 6 itself, and we put the 6 right there, then the fifth term will become x, which is 6. So the median would become 6. Do you understand?
Yeah.
Because we need to put the x somewhere, and we're free to choose where, right? Because x doesn't have a value yet, and we pick the value. So since we can pick the value and pick its position, therefore, and since we need the fifth term to be 6, we can just plug in 6 right there and make x 6. Okay? So let's try the part B now. So we want the lower quartile to be 2, which means that we need 9 over 4. What is 9 over 4? 9 over 4 is 2.25. So we need the third term to be 2, basically. Okay? So where do we put the x this time? What if we just put it here? As you can see, if we put it here, we will get the lower quartile to be 2. So if you put x there and you make x equal to 2, the lower quartile is 2. Okay? Is this making
All
sense?
right. Yep.
Yeah. Next up, we need to make the lower quartile 2.5. So this is the last one I'll do. The next one I'll leave you for homework. So if we want the lower quartile to be 2.5, then of course we need to plug in the x somehow over here, but we need to give it a specific value so that it makes the lower quartile 2.5. Okay. As of right now, the thing is, the lower quartile is gonna be, actually, I kind of made a small mistake here. Since this is 2.25, the lower quartile will be the average of the second and third term. Okay. So that is why if we put a 2 here, the average is going to be 2. So that makes the lower quartile 2. Now the question is, what do we need to put in this place for the average of these two guys to be 2.5? Because that's what the lower quartile is going to be. What do you think? What value can x be for for the average of these two guys to become 2.5? If you're confused, we can just write down the equation. We need 2 plus x over 2 to be equal to 2.5, right? The average of 2 and x needs to be 2.5. So we can solve this equation. Are you following?
Yeah.
Okay. So let's multiply both sides by 2 and then subtract 2 on the right side, which gives you x must be 3 in this case. So it must sit right there with a 3 value. Okay? So
Okay.
you can do a similar kind of, solution for the last part. I'll leave that for you as homework. Let me leave that in red so it's very clear. So when you're skimming through the notes, make sure that you try this one out. Okay? Okay. So for cumulative, the next idea is cumulative frequency. Cumulative frequency is essentially a running total of your frequencies. So you've seen a frequency table. So for example, let's say that I want to count the number of people that got scores from 1, 2, 3, 4, 5, 6, or 7 in their IBs. Okay. So their exam basically. And I make a frequency table where I show that. So this is the score and this is the frequency. So 3 people got ones, 5 people got twos, 6 got threes, 2 got fours, 1 got 5, 1 got 6, 2 got 7. This is a frequency table. However, I could add a cumulative frequency where I'm counting all the number of people that got every value and under that. What do I mean? Let's see. So, how many people got ones or less? 3 people. How many people got twos or less? 5 plus 3, 8 people. How many people got threes or less? Meaning all of these guys basically. That's how cumulative frequency works. Is that clear?
Yeah.
So basically, a cumulative frequency table shows how many data points are less than or equal to the highest possible value in each class. So we call these classes. Okay. So that's the basic idea of cumulative frequency. Now, um, how do you calculate the quartiles in cumulative frequency graphs? It's actually much easier to do than in regular sets. Because look, this cumulative frequency graph shows you that you have weight, so a weight of something from 0 kgs to 20 kgs. So, for example, if I want to know how many people, I don't know, how many, I don't know, boxes had a weight of less than 15 kilograms. So I'm not talking about how many boxes had a weight of 15 kilograms. I'm saying how many boxes had a weight of 15 or less. That will simply be, oops, that will simply be, so I trace 15 kilograms and I check the cumulative frequency. That looks like about 25. That means that exactly 25 boxes had a weight of 15 kilograms or less. That's how you can read this graph. Now, from this graph, it's very easy to check what the lower quartile weight is. How? This is important. To find the lower quartile, take your total frequency, 30, divide it by 4, because you want the lower quartile, which gives you 7.5. Trace 7.5 on the frequency diagram, reach the graph, check the value. This is your lower quartile, Q1. Okay. For the upper quartile, check what 30 times 3 over 4 is, because you want to find the 3 quarters now, 75%, which will give you 22.5. Check 22.5 on your y-axis, find the position on the graph, trace the weight, trace the class value. That is your upper quartile. And similarly for median, just do divided by 2, trace that, and check the value, and that's it. Okay, that's it. So you don't need to do any like rounding up. You don't need to mean anything. You don't need to average anything. Just simply divide by 4, check the value for the upper quartile, times by 3 over 4 to get the lower quartile. No, that's for the upper quartile. And then divide it by 2 for the median itself. Okay, that's basically it. So this is how you can find out the quartiles in a cumulative frequency graph. Now, for example, in this question, if you wanted to find the upper quartile and the lower quartile, etc., the first thing you would need to do is find out what your max frequency is. It is 80, right? So where is the lower quartile going to be? What frequency? What do you think?
Find a total of 18.
Yeah, so we'll divide by 4, which gives you 20. So we trace the 20, reach the graph, and read the class value, which is 27. So 27 centimeters is your lower quartile. That's it. What about the upper quartile? For the upper quartile, what should I do? 80 times?
304.
Exactly, which is going to be 60. So we trace 60 and we check the value, which is this, I believe, which is 43 centimeters. And for the median, what should I do? 80 times what?
Half 80.
Yeah, which is 40. So now you trace 40, reach this, find out the middle, which is 35 centimeters. So you found your median, you found your upper quartile, lower quartile. It's much, much easier than doing it with specific data points. Okay, so that's basically it for cumulative frequency diagrams. Now, we can talk about our next topic, which is going to be probability.